In this video, we're going to go over how to conduct a population mean hypothesis test for the student's t-statistic, where our n value, our sample size, is less than that 30 mark that we used for the standard normal test. So again, we have three possibilities for tests. We have two one-tailed tests and one two-tailed test. We're going to go through the two-tailed test again to start with because it's easier to talk about, and that's that center column on the picture. So for our null hypothesis, we have the same null hypothesis that we had from before, and that's mu is equal to mu naught, and the same alternative hypothesis where mu is not equal to mu naught. And then we have the same test statistic for all three possibilities. We have the test statistic as t is equal to x bar minus mu divided by s over the square root of n. And then our rejection region is where the absolute value of our t value is greater than t sub alpha over 2, where again we're picking our alpha for how much error we're allowing to have, and since it's a two-tailed test, we put half the error on the extreme right and half the error on the extreme left. So if our t value is greater than that t of alpha over 2, we reject and accept our alternative hypothesis. And that's again all based off of the degrees of freedom, which is that n minus 1 value. And then for the one-tailed test, we have two options. We have for the null hypothesis, for both of them, we have mu is equal to mu naught. And then for the alternative hypothesis, we have mu is less than mu naught for the extreme left side, and mu is greater than mu naught for the extreme right side. And we're just going to stick to one of those, and you can interpolate to the other one. So for the one-tailed test on the left of your picture here, where we're going to talk about mu is less than mu naught for our alternative hypothesis, we reject the null hypothesis if our t value is less than negative t of alpha. So again, we have all of the error on that left extreme. And again, it's based off the degrees of freedom, where the degrees of freedom is n minus 1. And you can use that to interpolate up to the rejection for the alternative hypothesis for mu is greater than mu naught.